Multistaging, also known as compound compression, is used to reduce the specific work input in refrigeration systems. In your two pressure systems, which is the regular refrigeration system, the compression is done in a single stage. In multistaging or compound compression, you compress the refrigerant in two or more stages. So this diagram, which is the pressure enthalpy diagram, what you see is that the compression is happening in two stages. First, there is a compression from 1 to state 2 in the compressor 1. This is the first compressor. Then there is a intercooling, that is the refrigerant's temperature is brought down, it is lowered, and then again there is a compression in compressor 2. So this phenomena is known as two-stage compression or compound compression. The advantage of compound compression over single-stage compression is that the specific work input gets reduced significantly in case of two-stage compression. What is the reason? The reason is, if you compare it with the single-stage compression, so if I want to represent a single-stage compression here, it would be shown like this. So this would be the single stage compression. So the dark line which I have shown, that represents the single stage compression. So let me call that end state as 2A. So 1 to 2A would be a single stage compression, and as you find the single stage compression, the specific work input would be the enthalpy difference across the compression delta H, which is nothing but H2A minus H1. In case of multi-stage compression, you have compression from 1 to 2 and compression from 2' to 3, and the work input would be H2 minus H1 plus H3 minus H2'. Now, the reason why, in spite of this addition of the two, this work is less as compared to the single stage work. The multi-staging work is less. The reason is, this line is away from the saturation curve as compared to the multi-staging case. This is a saturation curve, and this line is away from the saturation curve as compared to the multi-staging case. In the multi-staging case, you find that this line is closer as compared to this line, and when it is closer, the enthalpy difference is less. The reason is, as you move away from the saturation curve, the lines, these are the isentropic lines, the constant entropy lines, they become flatter. And when they become flatter, when they are more flat, this enthalpy difference is more. Okay, so this is a reason, this is an important reason why two-stage compression gives you a less work input, like less specific work input as compared to a single stage compression. So this is an important advantage of multi-staging over a single stage compression. There are other advantages also which we'll discuss later.